1939, the New York World's Fair. 1904, the St. Louis Fair. 1889, the Paris International Exposition. From earliest times, markets and fairs have been a gathering place where men came not only to trade, but to exchange ideas. As civilizations grew, as communications improved between nations, peoples of the world looked for new ways to display their industrial and cultural accomplishments. With the coming of the Industrial Revolution, the Industrial Fair was born. London, 1851. Over this world of squatting stones and twisting streets arose a strange and unbelievable structure, the Crystal Palace. It was built for and became the symbol of the London Exposition of 1851, the first World's Fair. With each succeeding fair, people came from greater distances. Fair buildings introduced new materials in daring engineering and architectural concepts. Timekeepers of progress. In 1889, there arose over Paris the theme symbol of the Paris International Exposition, the Eiffel Tower. Designed by the greatest engineer of his time, Gustave Eiffel. Magician in iron, he was called. The great tower was bold enough to be controversial. A masterpiece of structural engineering, it remained a celebrated landmark, a symbol of world's fairs everywhere. Then, one day in March 1963, notables of both France and the United States gathered at Flushing Meadows, New York, for the beginning of construction of Unisphere, theme symbol for a new World's Fair. Robert Moses, president of the World's Fair Corporation.
We looked high and low for a challenging symbol for the New York World's Fair of 1964 and 1965. It had to be of the space age. It had to reflect the interdependence of men on the planet Earth. And it had to emphasize their achievements and aspirations. It had to be the sign ashore for all visitors, dominating Flushing Meadow and built to remain as a permanent feature of the park, reminding succeeding generations of a pageant of surpassing interest and significance. What stronger, more durable, and more appropriate metal in the record of American constructive accomplishments could be thought of than stainless steel? And what builder more imaginative and competent than the United States Steel Corporation?
In most uncooperative March weather, René Legrand Eiffel, grandson of the creator of the Eiffel Tower, signaled the start of construction of Unisphere. The first member to go into place was one section of the USS Core 10 steel pedestal. Unisphere, the largest representation of our globe ever attempted. Unisphere, the largest stainless steel structure yet built. Stainless steel. Why? Because it is to become a permanent landmark, Unisphere must be virtually maintenance-free, yet remain enduringly beautiful. Stainless steel alone could do the job. Decoratively used for years by architect and designer, it was easy to suggest stainless steel's strength and beauty for a structure so large. Here's what our engineers went to work on. Assignment. For purposes of monumental beauty only, complete a feasible design for a stainless steel structure as high as a 12-story building. If Unisphere were to be harmonious when viewed from any angle, no diagonal bracing could be used between parallels and meridians. Take away such bracing, and conventional structural members normally get heavier and bulkier. But each structural member of Unisphere must appear light and attractive. Perched atop a sculptured base, which must suggest lightness and grace, Unisphere would have to withstand the enormous and changing forces of the wind, as well as its own weight. The continents and islands would act like sails, and wind pressure could exert forces nearly equal to the weight of the entire structure. Because Unisphere is open and its land area is irregular in size and position, the wind blows on either the outside or the inside, the front of a continent or its back. No past experience was available to calculate the wind forces because no one had ever built a Unisphere before, or anything like it. To meet this phase of the challenge, exhaustive wind tunnel tests were conducted at the University of Maryland. From these aerodynamic tests came the data that made design analysis possible. The mathematics of analysis posed its own peculiar challenge. Unisphere had to be completed by April 1964. High-speed computers were used to solve the thousands of problems that would have taken years if attempted manually. In the design of this large bridge, for instance, it was necessary to solve only 35 simultaneous equations. In Unisphere, one problem alone required a solution of 670 simultaneous equations. Design, analyzed, and approved, fabrication and construction could begin. Thousands of different pieces had to be cut, formed, assembled, and welded. Box girders, tubes, beams, channels, angles. Special automatic and manual welding methods were employed. An upper meridian section is welded. The South Pole is assembled. Land areas were fabricated and assembled on this turtle-shaped fitting table, which duplicated the exact curvature of Unisphere. Conformed to United States Army Engineering Corps contour maps, mountains and valleys are shown in exaggerated relief in order to achieve effective visualization of elevation. Wrapped to protect the stainless beauty, sections were shipped by rail and highway to Unisphere's site. Just ahead of the construction of the pedestal, 30 USS T-1 steel anchor bolts are set and the concrete base poured around them. First structural member to go into place is the South Pole. Next, one of Unisphere's largest members, a lower meridian, is carefully fitted into the South Pole and laid across the pedestal. Actually welded girders, the lower meridians will support the entire structure. Right at the site, many of the members are field welded into sub-assemblies nicknamed orange peel sections. To provide support and access, a temporary mast is placed along Unisphere's polar axis. When the structure is complete, Unisphere will be self-supporting and the mast removed. The southern hemisphere, like a giant bowl, is completed in 83 days. The bowl becomes a world of stainless steel when the last flag-top section is set in place. Now, addition of the land areas can begin. Delicate work. No job for windy days, though, because the sections act like big kites if not securely held. Continents and islands in place, it remains only to raise the 3 orbit rings. Weighing 3 tons each, the orbit rings are field welded into a continuous single piece 450 feet around. Special care is taken to protect the polished surface. To prevent bending, each orbit ring is lifted by 4 cranes, each attached at 3 points. An intricate communication plan and network links all hands. Precision teamwork means that the orbit rings rise slowly and evenly. About 50 stainless steel guy wires connect each ring to Unisphere, just as spokes tie a bicycle wheel rim to its axle. Strong and light, they are so difficult to see that the rings seem to float in space. Only 162 days after construction was begun, Unisphere is complete. Its challenge successfully met. Crystal Palace, Eiffel Tower, Trilon and Perisphere. Unisphere now joins these and the other memorable timekeepers of progress. A spectacular piece of open stainless steel sculpture, Unisphere is dedicated to man's aspirations towards peace through mutual understanding and symbolizes his achievements in an expanding universe.